On the morning of June 17, 2013, a glacial lake sitting 12,000 feet up in the Himalayas burst its banks. What followed was one of the most violent natural disasters in modern Indian history. The water rushing down the mountain quickly turned into a debris flow. This is a specific geological term for a churning slurry of thick mud and displaced rocks, some the size of commercial trucks, accelerating down a steep incline. When this mass hit the modern town of Kedarnath, the concrete hotels and multi-story guest houses stood no chance. The sheer kinetic energy of the rocks and mud pulverized them instantly. Within minutes, 21st century engineering was erased, taking thousands of lives with it. The valley was entirely reshaped by the brute force of the mountain. As the storm finally broke, the first aerial rescue teams arrived to assess the damage. Below them was a wasteland of pale rock and deep sediment, where a bustling pilgrimage town used to be. But right in the center of the debris field, something caught their eye: the ancient Kedarnath temple, a structure built over 1,000 years ago, was standing completely intact. The modern steel and cement buildings that surrounded it were sheared clean off their foundations. Yet this stone structure took a direct hit from the same avalanche and held its ground. Understanding exactly how this happened requires looking closely at the specific physical evidence left behind, starting with what lies directly behind the shrine. When the floodwaters receded, they revealed a massive 1,000-ton boulder resting exactly behind the temple's rear wall. This animation illustrates what scientists call a hydrodynamic wedge. When the high-velocity fluid flow of the debris struck the boulder, the shape and mass of the rock forced the current to split cleanly into two separate streams. By physically dividing that massive wave, the rock diverted the deadliest part of the payload, the mud and those truck-sized boulders, safely past the eastern and western sides of the structure. Deflecting a direct hit kept the walls from being crushed outward. But a shield alone doesn't explain how the temple survived the massive seismic shock of millions of gallons of water violently vibrating the ground beneath it. To figure out how the building absorbed that vibration, researchers from the Indian Institute of Technology, Madras, ran a detailed structural analysis on the ancient walls. Architects used multi-leaf dry-stack stone masonry, interlocking massive granite slabs without cement. Being unbonded, they have microscopic room to shift. When the debris flow sent intense shockwaves through the foundation, the individual blocks flexed and rubbed together, dissipating kinetic energy instead of snapping. This exact design allowed the temple to survive an even longer test of endurance. During the Little Ice Age, spanning the 13th to the 17th centuries, this entire building was completely buried beneath a thick, heavy glacier for nearly 400 years, enduring constant shifting and crushing pressure. The builders didn't try to stubbornly resist the mountain's movements. They designed a structure that could vibrate and breathe with the terrain, proving that flexibility is a far better defense than rigidity. Geologists classify the exact placement of that 1,000-ton boulder as a geological anomaly, a 1 in a million coincidence. But local residents immediately painted it orange and gave it a name, the Bhim Shila. That name connects directly to the origin myth of the site itself. According to the ancient epic, the Mahabharata, this exact valley is where the warrior Bhima tracked down Lord Shiva, who had disguised himself as a massive bull to avoid the Pandava brothers. The myth says Bhima grabbed the bull, and as it sank into the earth, its masculine hump remained above ground, becoming the triangular rock worshipped inside the temple today. Thousands of years later, a massive stone bearing Bhima's name appeared out of nowhere to shield that exact same shrine. In the high Himalayas, the laws of physics and the destiny of myth are inseparable. The sudden arrival of that protective stone was seen as ancient history violently repeating itself. But the geological forces shaping this valley are far from finished. The Geological Survey of India currently classifies the surrounding glacier system as highly active, meaning the terrain remains profoundly unstable. This modern scientific warning mirrors a very old prophecy recorded in the Shiva Purana. The ancient text states that one day, the two towering mountains flanking the valley, Nar and Narayan, will physically merge. When that happens, the texts predict that the Kedarnath route will close permanently, and the site of worship will be forced to shift to a new location miles away, known as Bhavishya Kedar. Whether viewed as a masterclass in ancient engineering, a geographical coincidence, or a divine shield, the stone temple stands proudly as a highly resilient marker of human faith. It remains intact for now, holding its ground against the slow, inevitable clock of the mountain.